welcome.
Thanks, welcome to our booth.
Thank you so much. Tell us a little bit about yourself, and then we're going to talk a lot about automotive.
Excellent. And ARM. Yes, I'm Brian Carlson, and I am based in Austin, Texas. I'm Global Marketing Director for NXP Semiconductors for automotive processors and automotive processing application solutions.
Big job.
Yeah, it's an exciting area to be in, definitely. And ARM is a key part of a lot of, basically all these new products that we introduce have ARM processors in them. So it's interesting and exciting products for this market.
Well, let's talk a little bit about the Arm NXP partnership, which is long running, and you have a lot of demos here.
Yes, definitely. And we're showing pretty much all the ARM technology, the A, R, and M cores, for applications, real-time microcontroller applications. So we show the full thing, including our latest. We just did an announcement here with the introduction or the launch of the S32G3 vehicle network processors. It has 21 ARM cores inside, so it really takes advantage of ARM technology. But we're also showing electrification, both battery management, and here we're showing dual inverter control, so we're driving electric motors. You can drive up to 4 electric motors in a vehicle. We're also showing connected vehicle with our orange box, which also implements ARM technology for the connected vehicle, bringing all the wireless technology together into one box, everything you can imagine to connect the world. So lots of interesting demos addressing the key trends of the automotive market, which we know, electrification, connected, autonomous, all of that, and now software-defined vehicle, which is really the hot thing right now, and being able to support that with silicon, ARM technology, and innovations that NXP is bringing to really make SDV a reality.
Talk a little bit about the new sort of architectures that are being deployed into automotive applications, because there's a lot of change going on.
Exactly. That's why this is exciting, because there's a lot of new, I would say OEMs across automotive are taking different approaches, but ultimately going towards the same goal of more of a zonal architecture, which what that is today cars are developed with electronic control units, ECUs, kind of a hardware-defined model where I have a box or ECU for a very specific function, maybe even just rolling up the window, doing the HVAC, controlling the motor. It can't scale going forward, and the world's moving more to software-driven, and that architecture just doesn't work. So what we see is consolidation of functions into larger processors, which, that explains the many cores that we have, ARM cores in a device, because they want to do multiple functions as a single device rather than multiple functions in multiple boxes. It brings a lot of cost savings, weight savings, and it sets up the future for these software-defined vehicles that allows you, instead of having a box, a hardware ECU, you can have a virtual ECU running on the ARM processor that can be uploaded, download, you can update it over time. So the car gets new functions, it gets improved, there's new capabilities over time in the vehicle. And so that's really what's going on. The architecture people are moving to are these zonal architectures, and what that is having a big computer in the middle, a vehicle computer that kind of controls the vehicle, the brain of the vehicle. And then you have these zones at the edges of the vehicle, which consolidates a lot of that functionality. Instead of having multiple boxes, you have multiple software machines running inside of a bigger processor. So what that does is eliminates all these wires that go everywhere. You have simplified Ethernet, which simplifies the whole architecture. It's upgradable in the future, so it gives you a platform for innovation going forward. So it's a real major change for the automotive industry going forward.
So you said sort of the phrase of the hour, software-defined vehicles.
Yes.
Let's talk a little bit about SOFI and the work that's going on there that we're all involved in to try to make automotive development that much easier.
Yeah, SOFI is actually a very important part of the SDV effort. NXP is involved heavily in that effort. We work closely with ARM and SOFI and the members. And actually this platform is a key platform, I believe, for that. And we're actually showing some of the key technologies that leverage into SOFI. SOFI is important because we innovate at the hardware level, enabling a lot of really key technologies like isolation technologies to enable all of this to happen, right? Real time, isolated, so there's freedom from interference of all these virtual ECUs. So we innovate there from the hardware level, but then there's this level of software and connection to the cloud, which is, I would say, non-differentiating, that's really key to the industry. If you don't have more of a standardized layer of software, then everyone, all the tier ones or OEMs are off spending billions of dollars to basically create the same wheel. So why not get the industry together, the industry leaders together from silicon, from OEMs, tier ones, cloud, with Arm, and just bring that ecosystem together, and that allows us to more standardize how that software-defined vehicle will all work together. And then you start to innovate on top, right? That gives you this whole opportunity to innovate and really take the SDV forward and realize the dream of what SDV is going to bring to the market, both to OEMs, the ecosystem, and ultimately consumers. So NXP is a part of that. This is a good example of a platform that is ideal working with Sophie because it allows us to deploy services, and we're showing here through Kubernetes. We're actually doing K3S, bringing data center technology into the vehicle, and that all ties into what Sophie's doing. And we have real-time, their Greenbox 3, which massive, 8 R50 Cortex R52 cores running at gigahertz, and now we can do lots of distribution of workloads into the real-time area of the control at the zones. So that's what's exciting, is the technology at the hardware level combined with making this kind of common standard level that the industry can use and not have to keep spending lots of money doing different versions of something like it, and then enabling the innovation on the top so that the SDV can come to fruition and grow very quickly, much like the smartphone with all of the applications we have today.
Yep. You mentioned you've been deeply involved in Sophie. You have any highlights from the last year and a half or so of your work there?
Well, I think the key thing is actually the work that's been done and being able to actually see momentum of realizing the dream and actually being able to deploy capabilities onto these types of platforms. So I think the key is seeing that progress actually happen. It's not just PowerPoint. It's actually people in action and making things happen. So overall, at a high level, I would say the progress that's been made, and I would say the momentum also, because you have to have the key ecosystem partners on board, and seeing that momentum over the last year. I was just at the Sophie reception on Monday, and we saw the momentum there. Large crowd, a lot of excitement, and it's a great way for the industry also to network and come together, exchange thoughts. So I think that's the big thing, is the momentum was starting to come out of it, and I think the next year is going to be even more exciting because we'll start to see more and more of that technology and results of that work come to market as we move very, very quickly to SDVs.
Well, speaking of networking, your booth is packed with people, and I'm going to let you get back to business. But thanks so much for your time, Brian.
Yeah, definitely. Thanks for stopping by our booth. Appreciate it.
The future is built on Arm.